We will now implement the second microservice, kafkatoelasticservice. Let's create a module kafkatoelasticservice and then start adding dependencies. We will add Spring Boot Starter, Spring Kafka, and Kafka Aura Serializer dependencies first. Then we also need to add Cloud Starter config and Starter security dependencies to be able to use config server. And finally, from local dependencies, we need Kafka consumer, Kafka admin, and Kafka model. Let's also add Spring Boot Maven plugin without built image goal to be able to create a runnable jar file. Then let's create a package com microservices demo kafkatoelasticservice, and then create a class kafkatoelasticservice application, which is the Spring Boot main class. Then we will annotate this class with component scan annotation, and for the base packages, we will set com microservices demo. And also, we will annotate this class with Spring Boot application to make it a Spring Boot starter class. And finally, in the main methods, we will call the Spring application run methods as we did previously. Let's now create the application configuration file, application YAML, and leave it as empty because we will use the properties in the config client kafkatoelastic YAML file in config server. We will then create the logback XML file and use the same strategy by using logback common file from the appconfig data module. And just by setting the dev home and app name properties in this logback XML file for the new microservice. We can now add the bootstrap YAML file. We will first add the Spring application name property as the kafkatoelasticservice. Then set profiles active as kafka_2_elastic. And then set Spring Cloud config properties, name, URI, username, and password. You can just copy them from the Twitter to Kafka service configuration file. The only changes are the Spring application name, profiles active, and cloud config name. Let's then add a package consumer and create an interface called Kafka consumer. We will use two generic variables, k extend serializable and v extend specific record base for key and value. Then we will create a single receive method here with 4 parameters, list of v for messages, list of integer for keys, list of integer for partitions, and list of long for offsets. After importing Java util list for this interface, we can create the implementation class in the impl package. We will create a class called Twitter Kafka Consumer and implement Kafka Consumer interface by overriding the receive method. For generic variables replacement, we will pass long and Twitter Aura model for key and message. Then we will annotate this class as service to make it a Spring managed bean. And then create a log variable. And finally create 3 fields to inject: Kafka listener endpoint registry, Kafka admin client, and Kafka config data. We will use these fields later. For now, let's just update the receive method with Kafka listener annotation, and then set an ID, like Twitter topic listener, and specify the topic. For topic, we will use a replacement with dollar and parentheses for Kafka config.topic name by getting it from the kafkatoelastic configuration. Here as a parameter, we have the payload as messages, so we need to annotate this as payload. And for keys, partitions, and offsets, since they are coming from the Kafka headers, we will annotate them with header and specify the key by using Kafka headers constants, like received message key, received partition ID, and offset. Then in this method, for now, let's just log that number of messages received with keys, partitions, and offset, and sending it to Elastic. We also specify the thread ID in the log message here. Alright, now I want to run this service. First, we need to commit the changes we did in the config server repository, because these changes should be pushed to the remote GitHub. Otherwise, our service cannot get the latest changes. So please go to the config server repository and commit your changes locally, and then push to the remote GitHub repository. After that, we need to do a small change to the services YAML file. Since we will now run everything inside Docker, apart from the service, kafkatoelasticservice, we need to reach to config server by localhost. Since we need to reach to config server using localhost, we need to open the port in the services YAML file. We will simply update the port definitions for config server and add 8888 to be able to reach to config server using localhost 8888 from the new kafkatoelasticservice. I set auto startup as true for now, as we are sure that Kafka cluster and other services already running, so no need to check initialization logic, which we will add in the next section, where we will set auto startup as false. After doing this change, let's check if you have anything running locally in the Docker. And then simply run docker compose up command to be able to run everything inside Docker, including config server and Twitter to Kafka service. After that, let's check if we have everything running correctly. And actually, we can follow the logs for Twitter to Kafka service by using the ID from the docker ps command results and using docker logs -f command. After we see the tweets in the Twitter to Kafka service logs, or maybe you can also use kafkacat here to see the tweets, and after being sure that curl localhost 8888 actuator health gives a correct response, we can now start the kafkatoelasticservice by just running it in IntelliJ. We should be able to see the tweets in the kafkatoelasticservice logs, because we are just logging them. Alright, I will see you in the next section.